right, hello guys. It's my first time actually speaking at ViennaJS, so thank you for having me. Um, I won't spoil who I am just yet. So today I'm going to talk about Three-VRM and Three.js and 3D avatars and really like obscure things like that. So without further ado, a small cat warning. You might see some cats on these slides because our designer really likes cats. So a lot of the default slides have cats, hidden somewhere in some shape or form. So keep that in mind. So a quick overview of what we're going to talk about today. So I'll give you a very quick speed run. We can call it that, of 3D CG. Then I'm going to talk a bit about 3D assets. What is glTF? It's not a new JavaScript standard or things like that. Don't worry. Then I'll tell you what the heck is VRM. It's not DRM. Then I'll give you kind of brief overview of Three.js, and then we'll get into like the actual guts of the talk, right? And of course, demo time at the end, because I heard you guys like live demos. So a little about me. So I'm kind of a full stack engineer. So I've dabbled in a lot of languages, and in my day job, I'm a backend developer at Platogo. We do like multiplayer gaming for millions of users. Yeah, I do like all sorts of web apps in my free time. That's how I got into this mess with TypeScript and JavaScript. What else? I am really interested in XR and 3D stuff. I don't want to say the word metaverse because it kind of got ruined, but I think it's coming back with the release of the Quest 3 and things like that. And I'm also a part-time streamer / VTuber. That's why you see like this 3D model of me pop up in some places. I was dumb enough to buy like the original Quest Pro for a full retail price, but it's still a really fun headset. And that's me. You might notice the hoodie is matching. So before we begin with the main thing, let's talk about 3D CG. I won't show you how to make 3D anime girls. Sorry about that. Like the very first concept you need to know is meshes. So what is a mesh? It is basically a collection of edges, vertices, and faces. It's how you describe 3D objects, their shape. Edges and vertices, I hope you're familiar with that. Faces, they can usually be polygons, so it can be some kind of rectangle. Most of the time it's triangles in computer graphics because triangles are easier to calculate. But at the end of the day, it is maybe a cube is the simplest mesh I can think of. It's just a few vertices, a few edges, and a few faces. So like a cube has 6 faces, right? Pretty basic stuff. And textures, if you've played any computer game, you're kind of familiar with textures already. It is some kind of image on a 3D surface. Like if you're playing, I don't know, Counter-Strike, then you basically know all the textures by heart of all of the walls, right? And shaders, something maybe a bit more technical. It is the implementation of material. I really like this description of what a material is. It kind of describes, how light interacts with the surface of some kind of 3D object, right? The simplest shader, I should have probably mentioned, a shader at its very core is a computer program. And it tells you how to actually render a point on a 3D object on a 2D screen, right? So the simplest shader literally just takes, the color of, let's say, a cube and puts, the 1 pixel of this red cube on your screen. That's the simplest example. Let's summarize all of this together. So 3D object usually has some kind of mesh. It has a material, and this material can have a texture and a shader, right? This is keeping it extremely simple. So what are the challenges of working with 3D graphics? The difficulty is actually, exchanging it. So you made, let's say, a 3D car or a plane or a train or something like that. And now you need to share it with others, or you made it in one program and you need to transfer it to another one. And this stuff was not easy, up until, let's say, 10 years ago. You need to keep, your mesh together. You need to keep your textures together in some way. Then you have other things like shaders. You have skins, cameras, animations, like all these things you usually use in game programming. You want to include metadata. And you might want to load these things at runtime. So you might make some kind of 3D game and you want to allow users to just drag and drop, let's say, a car or a cube or a ball or something as simple or complex. But there is a solution. It's called glTF. So what the heck is this glTF thing? It's basically, I would say, the JPEG or like the MP4 of the 3D world. So it's a royalty-free spec. It's also a file format in its own way. And it basically standardizes how you share 3D content. So there is already a version 2. So it's, been a while. And one of the greatest advantages it has, like over legacy formats like OBJ or FBX, is that it's a lot more compressed. The structure is a lot simpler, and you can really self-contain a lot of things, and I'll show you that a bit later. And it's royalty-free, very important. So you can read all of this. This is like a very simple explanation of what is glTF and what it can do. But we're not going to do that today. This is a bit easier to grasp. So at the very core of glTF, there is some kind of scene. And in the scene, you can have a node graph of different things. So you might see some very familiar terminology here, like a mesh that has a material, that has textures, that has some shader programs. Then you can bundle in animations. You can include cameras, you can have skins, like all the stuff you can describe in a standardized format. So you no longer have this problem of every studio, let's say, or every app making up its own proprietary formats that only work with version of Maya 2 or like Maya 3 or like Blender version 2.9 and not 2.8. So this solves a lot of problems. What else? So what about 3D avatars? So glTF, as you have seen here, is pretty versatile. You can do a lot of things with it. A small side note, you might have seen Kronos mentioned when Vulkan is mentioned. It's the same guys. So there is a thing called VRM, and this thing actually standardized 3D avatars, in games and on the web. So VRM is still relatively new. It's based on glTF 2.0. So you can base other standards on top of glTF. And there is one other called 3D tiles. And it basically allows you to stream, let's say, parts of a 3D map if you're building something like Google Maps or Apple Maps. All right, the same exact technology. And what does VRM solve? It solves all the things I really mentioned about glTF, transmitting 3D content between apps and devices and frameworks and things like that. So what are the difficulties of like 3D avatars? First of all, they have a lot of things under the hood. They have things like default poses. They have things like facial expressions. They have skins. They have bones. They have metadata that you want to include. And before something like 2018, this was highly fragmented. So everyone did it their own way. There wasn't really a standard, so it was really horrible to work with. And VRM kind of solved that. So this is the very, very basic structure of a VRM. So it contains some metadata. It can contain materials for your avatar. These materials can have shaders. You can include expressions. You can include visemes and blend shapes. Visemes, if you're not familiar, it is basically the description of fundamental visual representations of spoken sounds. So a, I, U, E, O, that is a viseme. Like let's say the A sound or the I sound or the U sound. And then you also have cool things like gaze, because 3D avatars, they have eyes, and you want the eyes to move. So it's actually pretty easy with VRM to rig and animate eyes and make them look where you want them to look. And yeah, so this is like the basic workflow of how you work with VRM. So you start with some kind of 3D creation app. Let's say it's Blender or Maya or VRM Studio. Then you end up with a VRM avatar. It's literally a single file. And then you import your VRM into end game engines or games or 3D frameworks. So it's actually this easy. Like this is a really universal format. And the VRM avatars in general, are a lot more flexible and a lot more, let's say, detailed compared to some proprietary solutions. And there's even entire hubs like VRAID Hub, which is like the GitHub of VRM avatars. I'll call it that way. So someone had a question. Okay. So now that we explained all of this like fundamental knowledge, we can actually get to like the important stuff. So we finally got to the web, Three.js. Maybe you can raise your hands. Who has tried Three.js before? Okay, a fair amount. So for those that don't know, Three.js is basically a framework that allows you to really easily create 3D content on the web so that you don't have to do things manually with WebGL and Canvas. And it's supposed to be extremely straightforward for almost any web developer to use. So the learning curve is actually quite okay. Yeah, basically what I said. So a lot of things in 3D CG and 3D game programming or just building 3D stuff is pretty hard, and Three.js makes all this a lot easier. So you can pretty easily create things like scenes and lights and shadows and manage materials, manage objects and import glTF. That's already built into the framework. So at the core of Three.js is a scene and a renderer. So a scene is, you can think of it as a graph of nodes, and each node represents some part of your project. So one example is, let's say, a cube. So this cube would be an object 3D, and it has a mesh, and this mesh has a geometry. And this geometry is usually some kind of pre-built template geometry in Three.js, like a cube. And all of this is very object-oriented, let's say, in Three.js, but it's also extremely composable. So you can have different meshes. These meshes can share the same geometry. So let's say you want to build 20 walls. You only need to create one geometry for a wall, and then you can reuse it 20 times. Then you also have materials, like I explained before, and these materials can again be shared between different meshes. And these materials again can have textures. Then you have lights in your scene, because without lights there is nothing. You will see total blackness. And you might be asking yourself, why is camera like way over here and not like somewhere here? There's a good reason for that, because cameras in Three.js can become children of different objects. So they are pretty dynamic entities, in the world of Three.js. especially since you want to move them around or you want them to track different objects and things like that. So we got all of this hard stuff behind us. Now you're prepared to learn what is Three-VRM. So Three-VRM is a library or like an add-on for Three.js that is made by Pixiv. It is this tech company from Japan, and their main product is an illustration sharing website, pixiv.net, very reasonably named. And basically what they did is they made an entire library to make it very easy to work with VRM in Three.js. It's as easy as loading, let's say, a cube. And then you have your 3D avatar in any Three.js scene. So I think it's time for a demo. Let's see how well this works. I did deploy this here, but the thing I'll have running on my laptop is a bit newer. So if you're curious, you can open this up on your phone as well. If it's visible, I leave this on there for like 10 more seconds. All right, I'm gonna switch. All right, there we go. Yeah, I'm just gonna reload this. So here we have a Three.js scene. This is just a Svelte component in the Astro.js app. I know, very complicated setup, but it works. So what we have here is drag controls. So this is pretty easy to do in Three.js. You can add any controls you want almost. And here we have a VRM avatar loaded into Three.js. So one of the things we can do is, this thing is reactive. We have things like animations. So let's switch to silly dancing. There we go. That's cool, right? All right, we have a few more here, like flare. I don't know what this one is. All right. So
I want to see it in real.
Maybe in a few years. So down here, we have this thing called metadata, and I'm going to zoom in on this a little bit. So I talked that each VRM avatar has metadata, and this is, built into the standard. There's two versions, version 0 and version 1. I won't tell you what the differences are. But basically, you can define basic things like the author name, like the commercial usage, the license, and things like that. There is this pretty interesting metadata field, which is slightly misspelled, and this is actually in the standard. Pay attention to this value here. You even have things like, is it allowed to be used in violent usage? And you can add a few other things. These are optional, but they did think of a few different use cases for VRM already in version 1. So not bad. Next, what I wanted to show you is, I should actually probably mirror my screen, otherwise I'm gonna break my neck like this. Give me like 1 second. Mirror. And I'm gonna make this a tiny bit bigger. So I actually added this object of the VRM right in here into the window object, so it's a bit easier to explore. Yes.
Can you maybe pop the console on the other side?
Yes.
Unless you need it.
There we go.
Nice.
Perfect. So if we look at this object, it has a few different things inside of it. So the first thing we can look at is materials. So here are all the materials in just this one avatar. And what is mToon? mToon is a pretty standard shader in like the VRM world, which basically tries to mimic a sort of anime-ish look. So it has a few basic shades because when you look at anime, there's usually like the main shades, and then there's a pretty strong-ish shadow, like a second shade. So it has, I think, only 2 or 4 different shades usually. And you can see everything that there is about this material. And probably the most interesting thing is that you can look at the actual shader implementation right here. So that's it about materials. Yeah, there's a lot of stuff. So there's another thing called an expression manager. What this allows you to do is to control all of the blend shapes and all of the visemes and expressions that you have in your avatar. So let's maybe stop this dancing so we can actually look at my face. Breathing idle, there we go. And we need to like drag this around a bit. Boop, boop, there we go. So if we access this like expression manager, we can actually look at all the expressions that we have under this expression map. And as you can see, there are a ton. And I did change this VRM avatar a bit, so it has a bit more than what you usually get. So we have this happy expression. So how do we actually use this? There is this method called setValue, and it is as easy as setting a float value like this. And there we go, I'm happy. How cool is that, right? So we can set it back to 0, and you can of course combine these together. But when you have more complex expressions like happy, it's actually multiple sub-expressions together, like blink left eye closed and blink right eye closed, and another one for your mouth. What else can we try? Of course, we have blink. Let's try blinking our left eye, because why not? So this would be blink left, and let's say 1, 0. Boom, there we go. We can reset it back to 0. So there are a ton they can play around with. And that's just the expression manager. So of course, every VRM is also made up of a humanoid, and this humanoid has bones. Who would have thought? And there are a ton of bones, like for your chest or for your head or for your hips or your left hand and each finger as well. And you can control each one of them individually as well. And that's actually how the animations work. Like at the very roots, an animation is just a change of values over time, right? Okay, so that's enough for doing stuff in the console. Let's actually maybe look at some code. I won't show like too much, but I think it's a good idea to look at something. So here, this is the very basic setup of a Three.js scene. So you have a canvas, then you have a render, then you have a camera, then you have a scene. You need lighting. We don't have this, so let's delete that. Look at targets. This is something you can use to actually make your avatar look somewhere. So the cool feature of Three-VRM is that you can create a target in 3D space. It is just a 3D object, and then you can make your avatar look there. So you can do things like make your avatar follow the cursor on the screen and things like that. And a loader, under the hood, this is just a generic glTF loader. It's built into Three.js, but you use the same one to load anything from a blimp to an avatar. Then let's scroll all the way down to this load function. So here you specify your model that you want. You have a callback that gets called when it's finished loading. And this is where you can actually extract data about your VRM avatar. So These things are performance optimizations. Let's not talk about them right now. Frustum culling. I should have maybe explained what the hell is a frustum if you're not familiar with like game programming. A frustum is basically the space in the field of a camera, a virtual camera, where things actually get rendered. So you can think of it as a cone going from your camera, and there is a near field and a far field, and everything that is between these two actually gets rendered to save on performance. So what we say here is that we don't want this for our avatar. We render everything. This is, some ugly stuff just for the sake of the demo. And that is basically it. All you need is this callback. Then you get your VRM avatar and you add it to your scene with the scene add. That's literally as easy as it is. And maybe I can briefly mention that every Three.js project usually has this animate loop where everything actually happens. The most important thing is this render function where you give it a scene and a camera. That's all there is to it. One more thing I wanted to show you is, I'm trying to remember what. Yeah, so actually, we are standing on a blimp right now. Just something I added like very, very last second. And you can see here that like anytime we switch the select, we load a new animation and things like that. And I also wanted to show you, this VRM.dev website. So you won't find a lot of things here. So the way you learn about Three-VRM is that you go to this website, you read everything you can in pretty broken English, and then you try to make sense of it. That's like the workflow. But seriously, the best way to learn about Three-VRM is to actually go into their GitHub repo and just read the example code. So for example, if I wanted to learn about lookat, you just read the example code, and they also have an interactive example right there and then. So I can show you a couple if we have some time. Yes. I think we do. Okay, perfect. Yeah. So one I wanted to show you is lookat. So they also have some kind of basic VRM avatar, and you can see that it follows the cursor around, right? And one other one is maybe, animations. We're not going to do that in my demo right now, but yes, you can do, very simple things like this. And right, what I actually want to show you is how the hell did I add these animations? It's actually kind of simple. So you go to this website that is owned by Adobe called mixamo.com. And it's basically one big library of almost every animation you can think of. So you don't even have to make your own. So let's say you want something from sports. I don't know. And there's even very specific things like swimming. Doesn't look like swimming, but...
What do they use for rendering this animation? Also free?
I wouldn't be surprised if it's also free. But I think they use a different loader, like not VRM, but like FBX or something like that. So we can actually try doing this live. Like I'll show you how easy this is. If the Wi-Fi is fast enough, I hope. Nice. All right, so what I usually do is, let's look at my files. There we go. So we just downloaded this animation file, and it's an FBX. So we're going to put it into our animations. Don't look at this really horrible code. We're just going to add it to this map for convenience. Thanks, Copilot. And if we go back here, just going to reload. Boop. All right. Oh my God, I think it doesn't like these second screens or the zoom. Now we have swimming. Like, how easy was that? I am like swimming kind of in space, but that's fine. Let's ignore that. But you saw like how easy this is once you set it up. The only problem is that there is no like built-in way to do this. The way it works under the hood is I grabbed this Mixamo loader from like the official Three-VRM examples. Then I had to convert it to TypeScript because it didn't exist in TypeScript, and make it a bit more async because before it was kind of callback hell. And then what it really does under the hood is map all of the bones in the Mixamo world to the bones in the VRM world. And then it's really as easy as like drag and dropping an animation in your assets folder and referencing it. So I think that's almost everything I wanted to show you. If I can find my slides, which are not here, because I have one final slide. I cannot find my presentation window anymore. There's too many windows. Here it is. There we go. So I just want to say thank you. That is the most important slide. Yeah, you can find me everywhere, and I'll publish the slides with all the links somewhere. Thank you. I hope that was insightful.